When we first started, like I said, it was an Air Force Research Lab conference, and at that time you guys were just in a support role. But it was primarily aimed at people who would use the facilities we had atop Haleakala. And so it's kind of focused simply on space surveillance. I couldn't have even made this something that I had hoped to achieve. It just never occurred to me it could become this big.
I think the growth of the international community, we really tried hard to market the conference and connect with the international community. We've made annual sweeps through Washington, D.C. and attending similar conferences over the years to try and build credibility and our AMOS conference brand.
Maybe I just lacked the imagination to imagine what it could be like in another 25 years. Because the one thing, over the years people have said, you could make this conference bigger if you moved it to the mainland and have bigger facilities. It's like, yeah, it would not be the same conference. And we probably wouldn't get the same number of attendees.
Aloha kakahiaka a me e komo mai. Good morning and welcome to the 25th AMOS Conference, presented by Maui Economic Development Board. Please welcome Victoria Sampson to the stage.
Good morning, everyone, to the second day of the 25th AMOS Conference. My name is Victoria Sampson. I'm with the Secure World Foundation. I'm delighted to be here and excited to see everyone here in the audience and continuing the great conversations that were started yesterday. It is my great honor to introduce our keynote speaker. Hiroshi Yamakawa, the president of JAXA, has a master's degree in engineering and received a PhD from the Department of Aeronautics, School of Engineering in the University of Tokyo. As an associate professor at JAXA, he engaged in mission design of numerous Earth-orbiting scientific satellite projects, as well as lunar and planetary missions. He also engaged in the navigation, guidance, and control systems of the solid propellant rocket, MV, and liquid propellant reusable sounding rocket, RVT. He moved to Kyoto University in 2006 as a professor of the Research Institute of Sustainable Humanisphere, a professor of the Graduate School of Engineering Cooperating Chair, and a deputy director of the Unit for Synergistic Studies of Space. His academic interests lay in orbital mechanics, trajectory optimization, and space situational awareness. He was appointed as Secretary General at the Secretariat of Strategic Headquarters for Space Policy, Cabinet Secretary, Government of Japan in 2010 through 2012. Then he was assigned a member of the Committee of National Space Policy, Cabinet Office from 2012 through 2018. And then he was appointed the president of JAXA in April 2018. Please join me in greeting him to the stage. Thank you.
Well, good morning, everyone. I'm Hiroshi Yamakawa, as introduced. I'm president of JAXA, Japan Aerospace Exploration Agency. Well, first, I would like to thank Leslie, Sandy, and Jeannie of Maui Economic Development Board, MEDB, for hosting this wonderful AMOS conference for years. And congratulations on the 25th anniversary of AMOS. Today, I think I will talk about first about a little bit of national policy, space policy of Japan, government of Japan. Then I will, because this is my third or fourth AMOS conference for me, but the last time was more than 7 years ago, so I'm very happy to be back here. And so I would like to talk a little bit about what JAXA is or what JAXA is doing. And in the latter half, I will talk about the SSA-related activities of JAXA. Okay. So the first slide is not so interesting, but it's about the national space policy. And the basic space law in Japan was enacted in 2008. Since then, there are several national space legislations such as Space Activities Act, Remote Sensing Act, and Space Resources Act. And the next slide is the framework between, because AMOS is hosted in the United States, I'd like to talk something about the Japan-US space cooperation framework of the two governments. And there are lots of dialogues, bilateral agreements, multilateral agreements. And on the slide, you can see several, on the left side, you can see space security-related agreements. And because AMOS is the SSA conference or SDA conference, I'd like to show one of the US-Japan Space Situational Awareness Services and Information Agreement, which was signed by two governments about 10 years ago in 2013. So we are having cooperation with the United States based on this agreement. And this slide shows the structure of the related to space of the Japanese government. And on the top, you can see strategic headquarters for national space policy. As Victoria introduced, I used to be the Secretary General of this space policy headquarters. And on the you can see JAXA down of the slide, bottom of the slide, and you see many ministries who have some space budgets. And in Japan, there are about 10 ministries which has some kind of space budget. And JAXA is cooperating or having contract with almost all the related ministries. And JAXA is actually has started as a R&D space agency. But as you know, JAXA is actually developing, launching, and operating rockets and satellites. So we are also defined as implementation agency. Implementation means that we are actually doing something in space. And just recently, the government defined JAXA as the funding agency. So we have now 3 roles: R&D, implementation, and funding roles. So that's the definition of JAXA right now. So JAXA has been engaging in every aspect of space, including SSA. This is not so interesting, so I'll skip this. Not so interesting, but I just want to say the total budget of the Japanese government related to space is about $6.4 billion US dollars, and about 1/3 or 1/4 of the budget goes to JAXA. So that's the ratio between the whole budget and JAXA budget. And you see an increasing tendency. So that means that the Japanese government is strongly supporting us, or space community. I'll skip this. So now I would like to introduce some of the recent JAXA activities in space. The first one is SLIM, which means Smart Lunar Landing Mission. And on the picture, the beautiful picture on the left, it was taken by a small robot which was deployed from the main lunar lander just before the landing. So you see a very beautiful real photo of the lunar lander and also the surface of the moon. The big point of this SLIM lunar lander is the first Japanese lunar lander, but at the same time, the world's first lunar lander which demonstrated a pinpoint landing technology. Pinpoint means that the precision of the landing was well within 100 meters. Actually, it was about 10 meters. And this was realized by image-based navigation. So the image taken by the camera on board the lunar lander was compared with the map of the moon, so that this lander could navigate itself based on those images. That's why it realized a 10-meter precision landing. So this happened this January. And the next topic is about our rocket. We have been operating what we call H2A rocket for 20 years. And we will, this year, we hope to launch, this fiscal year, we will hope to launch 2 more, and then 50 launches, 50 H2A rockets will fly to space. But the next generation is called H3. So this H3 rocket, we were successful in test flight number 2 in this February. And so from this year, we think that this H3 rocket will be our main rocket for our, not only for JAXA missions, but also for governmental missions, international missions, commercial missions. So we are hoping to launch more this year. And the next topic is about exploration. So JAXA is participating in the Artemis program, and one of the main contribution is a pressurized rover. It's a manned pressurized rover so that it can realize a kind of a sustainable exploration on the surface of the moon in the early 2030s. And this April, the Japanese government and NASA signed implementing arrangement regarding this pressurized rover in Washington, D.C. You can see Senator Nelson of NASA and our minister. And the point is that JAXA is collaborating with Toyota to develop this pressurized rover. It's the size of a small bus, and the 2 astronauts will drive or stay inside or outside sometimes the rover for about 2 months in total. So I think this is going to be a very exciting mission. And this May, we were also successful in launching Earth observation satellite. The name of the satellite is called EarthCare. And this EarthCare satellite is a joint project between European Space Agency, ESA, and JAXA. And JAXA provided one of the main instruments, which is called CPR, which means Cloud Profiling Radar. And the data on the right shows some cloud observation with in-depth. So the point of this sensor is it can measure cloud in 3D. So that's the point. So right now we are in early operation of this EarthCare satellite together with ESA, European Space Agency. By the way, this EarthCare satellite was launched from Vandenberg Space Force Base. And also, 2 months ago, this ALOS-4 another Earth observation satellite was launched. It is called ALOS-4. This time, this ALOS-4 was launched from Japan, utilizing H3 rocket, which I've just mentioned. H3 rocket number 3 successfully launched this Earth observation satellite, which is an L-band radar imaging satellite. And this radar satellite will mainly utilize for disaster monitoring, disaster response, and sometimes we will also utilize this satellite for national security purposes, and sometimes for tackling global warming phenomena. And just recently, we had a very exciting moment together with NASA. It's about sample exchange between NASA and JAXA, and what kind of sample? It is an asteroid sample. You may know that JAXA has returned a sample from an asteroid called Ryugu in 2020 with Hayabusa 2 spacecraft. And we already provided some of the asteroid sample to NASA several years ago. And just recently, as you know, the NASA OSIRIS-REx mission, a spacecraft returns samples from Bennu. So based on the agreement or implementing arrangement, we exchange samples between us in order to maximize the scientific output. Now, I will go into speak about our SSA activities. Well, first of all, we have ground sensors. One is optical. We have optical sensors and radar sensors, and we have those facilities in the western part of Japan, as you can see in the map on the right. Again, I have to talk something about the space policy, and the Japanese space policy document, which was issued last June, stated that the government of Japan will establish a SDA system, SSA system, to ensure safe and secure, stable utilization or use of outer space. And it says that the JAXA will provide continuous technical support for SSA. The point is continuous support, so we will do it for continuously. So we are engaging in SSA related activities in 4 ways. Number one, of course, we are operating our own SSA system to protect our own satellites, JAXA satellites. And number two, we are contributing to government of Japan SSA system as noted in the policy document. And number three, we are trying to contribute to international rulemaking for sustainable use of outer space. And finally, we are engaging in R&D on active space debris removal. I will talk about those. So this shows the architecture of the SSA system. As I said, we have ground optical and radar ground sensors, and we are operating this in order to avoid collision between JAXA satellites and other space objects. And at the time we are contributing to the government of Japan SSA system, that means that Japanese MOD, Ministry of Defense, or Self-Defense Force recently established its own ground radar system. So we are contributing to that kind of system. And right now, the Ministry of Defense is in charge of the government of Japan's SSA system. And the full-fledged operation has started last March. And of course, as I said, we are doing our own SSA system to protect our own satellites. But at the same time, we have a direct interface with a Japanese MOD SSA system. And so we are doing information exchange together with JMOD. And also, as I said, we are collaborating with US DoD under the SSA data sharing agreement, which was signed about 10 years ago. So this is the current framework. And this slide shows our SSA, sorry, it says SAA, but it means SSA facility. We have radar and optical. And this is one of the examples of, again, SSA, but our telescope observation data, which observes the sample return capsule, which was released from Hayabusa 2 spacecraft, bringing samples back to the Earth from an asteroid. And we are engaging in SSA activities daily, and the number of the notification from CSPOC is increasing drastically recently, and of course, based on those data, combining those data together with the JAXA data, there are so many tasks for our SSA team to do every day. And last year, but finally, the collision avoidance maneuver, we did it 6 times. It seems not many, but it's every day. JAXA SSA team is working hard to avoid collision, of course. And talking about international contribution to rulemaking, JAXA promotes international discussions to establish a kind of international rules or code of conduct for space debris mitigation in cooperation with the Japanese government and ministries. And we are contributing to IADC, which means Interagency Space Debris Coordination Committee, for decades, and other international fora such as United Nations COPUS and ISO. And we are also establishing standards for management and design related to SSA or sustainable use of outer space. And just recently, we established a standard for on-orbit service. You see at the bottom of the slide. And this standard for on-orbit service is actually used in the active space debris mission, which I will talk soon. And it seems there's no time, so I will skip this one. And finally, I would like to talk about the R&D related to SSA. And one of the highlights is active space debris. And for active space debris removal, we have to develop so many technologies such as related to rendezvous, proximity operation, capturing the non-cooperative target space debris, and doing many complicated maneuvers. So we are doing that kind of, we have been developing that kind of technologies in the past in many projects. And finally, we are right now developing, promoting a project called Commercial Removal of Debris Demonstration. I'd like to talk why commercial, because everyone understands that SSA is very important, but at the same time, JAXA thinks that refining space environment is very important for our future. So that means that we have to remove space debris. Not every space debris, but the larger one. So our target is a large space debris. And of course, we are focusing on JAXA origin or Japanese origin space debris. Otherwise, it will be considered as will have a negative effect in the world. So we're focusing on our own, space debris. So of course, JAXA can do it by, if JAXA is doing by itself, then we have to, we can do just once or twice, but that's not enough. So we have to make it sustainable endeavor. So that's why we have to collaborate with private sectors from the very beginning in order to make it a kind of business. And so we split this activity into 2 phases. One is, the first phase is already started this year. And the first phase objective is to demonstrate non-cooperative rendezvous with the target space debris, and also proximity operation, and finally inspecting the target space debris. What's the spin rate? What's the surface material looks like? Or those things observed utilizing this space satellite. And in phase 2, we hope to realize it within 2 years from now. Based on the data taken by phase 1, we will actually capture the target space debris and remove from the current orbit. So that's our plan. And today I can show the result of the first phase 1. As I said, it's very important to cooperate together with the private sectors. And our partner for this project is Astroscale Japan. And this is the satellite. Astroscale named the satellite Address J. And with this satellite, by the way, this satellite was launched by Electron rocket from New Zealand, and this February. And this satellite successfully carried out the fly-around observation service in compliance with the safety requirements, which are set by JAXA. That means that the standard for on-orbit service, because the safety is the priority. You can see so many beautiful pictures, but I can show a movie. So these pictures were taken by Astroscale satellite, Address J, this July. And this doesn't mean that the target space debris is spinning or rotating, because the Address J satellite is flying around and taking pictures. So based on this, I think this is very, unusual photo, because this is the real space debris. And by the way, this space debris is a rocket body, second stage rocket body of H2A rocket, which was launched about 15 years ago. And as I said, next phase, we are also going to partner with Astroscale Japan for the phase 2, and we hope that we will realize a real capture and removal of a large-scale space debris to demonstrate this kind of technology. So we are willing to do both. Both means technology demonstration and also rule-making for space debris or space environment. Okay, thank you very much.
Thank you, Yamakawa-san. We appreciate your remarks, and he has graciously agreed to take some questions. So we have a few minutes for that. Quite a few questions from the audience. I'll try and combine them. Big picture question. The next panel is going to be talking about SSA in the Asia-Pacific region. Be curious to know, is JAXA involved in your regional cooperative efforts for SSA? How do you view your role in the Asia-Pacific region for SSA?
We are having many discussions, dialogues with our Asian partners. So we are, right now, I cannot say anything specific. We are trying to do some collaboration with so many countries in Asia-Pacific region. So that's the current status.
That's good to hear. You also, in one of your slides, you talked about sharing SSA data with the U.S. government. Be curious to know, are there other governments you're sharing SSA data with, or non-Japanese operators, like maybe working with the EU SST or someone like that?
As far as I know, as far as JAXA is concerned, we are sharing data only with the U.S. right now.
Are there plans to change that?
Good question. I think there might be, but not yet.
Okay, maybe at next year's conference we can get an update.
Thank you.
Are you guys working with any commercial SSA providers to use their capabilities?
Maybe, but not yet. Yeah. I'm sorry, always not yet, but...
Another TBD.
Yeah, TBD.
That's right. It's a growing and evolving field.
Yeah.
Okay. I think one last question, because I know we're running close to time. So JAXA has a role in the government space strategy fund for startups in early phase companies. Is there any emphasis on SSA-related services or technology in that fund?
Is there any?
Any emphasis on SSA-related services or technology in that fund?
I'm sorry, I'm not sure, but there are so many topics included, so maybe, but I'm not sure.
You have a lot of fires going
Right
on
now, we're in the selection process, so
Okay.
maybe I can talk it next year.
Next year. All right.
Yeah.
Someone's angling for keynote next year as well, apparently. All right. Okay, I think we're actually right at time at 8 o'clock. So everyone, please join me in thanking Kama-san for his excellent remarks.
Thank you very much. Thank you.